So let us discuss remaining questions of partial derivative. So this question says that f is basically a function of u comma v, and my u is basically e raised x cos y, and v is basically e raised x sin y, and we're supposed to prove this relation. So for that, first we need to calculate del f by del x. So my del f by del x will be basically del f by del u into del u by del x plus del f by del u into del f by del v into del v by del x. I have done this because my f is function of u and v, and they are then function of x and y. So this thing will be equals to del f by del u into del u by del x is basically e raised x cos y, that is u only, plus del f by del v into del v by del x is del u by del x is basically e raised x cos y, and del v by del x is e raised x sin y, and this is equals to u only and this is equals to v only. So this thing will be equals to v. So from here, if I calculate del square f by del x square, so I'll be getting del by del x into u into del f by del u plus v into del f by del v. So this will be equals to del u by del x into del f by del u plus u into del by del x into del f by del u plus del v by del x into del f by del v plus v into del by del x into del f by del v. So this is equals to, we know that del u by del x is u only, so it is u into del f by del u plus, from this term we'll get v into del f by del v plus u into I can write this term as u into del y del u into del f by del u into del u by del x. So this basically gives me u into del square f by del u square into del u by del x is basically u, so it will be plus u square into del square f by del v square. Likewise, this term I can write it as v into del by del v into del f by del v into del v by del x. So this thing is basically equals to v only, so I'll get plus v square into del square f by del v square. So this is the value of del square f by del x square, that is this. Now we are also supposed to find del square f by del y square. So del square, for that first we need to find del f by del y. So that will be basically del f by del u into del u by del y plus del f by del v into del v by del y. So let's find out value of del u by del y. So my u is basically e raised x cos y. So from here del u by del y will be minus e raised x sin y, and my v is basically e raised x sin y. So this is equals to minus v, and del v by del y will be e raised x cos y. So this is u only. So using these, I'll get del f by del y as minus v into del f by del u plus u into del f by del v. So if I calculate del square f by del y square, that will be minus del v by del y into del f by del u minus v into del by del y of del f by del u plus del u by del y into del f by del v plus u into del by del y into del f by del v. So let's just solve this and see what we get. So we know that del v by del y is basically u, so it will be minus u into del f by del u minus v into, I can write this term as del by del u into del f by del u into del u by del y plus del u by del y is basically minus v, so it will be minus v into del f by del v plus u into, I can write this term as del by del v into del f by del v into del v by del y. So we got it as minus u into del f by del u minus v into del f by del v minus v into del square f by del u square into del u by del v, that is minus v, so it will be plus v square plus u into del square f by del v square, and del v by del y is basically u. So I'll get this. So if I sum, that is this, let's name it as 1 and 2. So if we add 1 and 2, so we'll get del square f by del x square plus del square f by del y square is equals to u del f by del u plus u del f by del u plus v del f by del v plus u square del square f by del u square plus v square del square f by del v square minus u into del f by del u minus v into del f by del v plus v square into del square f by del u square plus u square into del square f by del v square. So this term balances this one and this balances this. So we'll get u square plus v square into del square f by del u square plus u square plus v square into del square f by del v square. I have clubbed in this and this term with this term. So again I can take u square plus v square common, so I'll get del square f by del u square plus del square f by del v square, and that's what we are supposed to prove in this question. So let's move on to next question. So the next question says that u is basically cos inverse of this and we're supposed to find out value of this. So this is a similar question that we have done. We'll use basically Euler's theorem here. So my u is this, so from here I'll get my cos u as x plus y divided by under root x plus under root y, and you can take x as common from numerator and under root x as common from denominator. So this will be equals to under root x into 1 plus y by x divided by 1 plus under root y by x. So you can observe that cos u is basically a homogeneous function and its degree is 1 by 2. So let us assume that z is equals to cos u. So by Euler's theorem we have x into del z by del x plus y into del z by del y equals to n into z. So let's just calculate value of del z by del x. So that will be minus sin u into del u by del x, and del z by del y is basically equals to minus sin u into del u by del y. So let's just substitute it here. So we'll get x into minus sin u into del u by del x plus y into minus sin u into del u by del y is equals to n, that is 1 by 2 into z, that is cos u. So from here I'll get x into del u by del x plus y into del u by del y is equals to cos u by 2 into minus sin u So this is equals to minus cot u by 2. So let's see, we are supposed to find out value of this only, and its value is basically minus cot u by 2. So the next question says that they have given us u as a function of x and t, and where a, g and n are basically positive constants, and it satisfies the heat equation, that is this, and then we are supposed to show this relation. So what we'll do is we'll just calculate a value of del u by del t and then del square u by del x square, and then substitute it in heat equation. So u is basically given to us as a into e raised minus gx into sine nt minus gx. So from here del u by del t will be basically equals to a into e raised minus gx into cos nt minus gx into n. Likewise del u by del x will be basically minus ag e raised minus gx into sine nt minus gx plus a e raised minus gx into cos nt minus gx into minus of g. So let's take minus of g as common. So we'll get a into e raised minus gx sine nt minus gx plus a into e raised minus gx into cos nt minus gx. So we can write it as minus g into, this is basically the u term, so it will be minus g into u plus, and value of this we can calculate it, or maybe let's keep it in this form only, plus a e raised minus gx into cos nt minus gx. So now del square u by del x square will be basically equals to minus g into del u by del x plus a into minus g e raised minus gx into cos nt minus gx plus a e raised minus gx into a minus sine nt minus gx into minus of g. So if we simplify it, I'll be getting minus g into del u by del x, that is basically minus gu minus ag e raised minus gx cos nt minus gx minus ag e raised minus gx into cos nt minus gx, and it will be minus and minus plus, so it will be plus g into a e raised minus gx into sine nt minus gx, and a into e raised minus gx into sine nt minus gx is basically u, so I'll get minus g into minus gu, and it will become minus 2ag e raised minus gx into cos nt minus gx plus g into u. So this balances this, so we are left with 2a g square into e raised minus gx into cos nt minus gx, and by heat equation we have del u by del t equals to, by heat equation we have del u by del t equals to mu into del square u by del x square. So my del u by del t is basically a e raised minus gx into cos nt minus gx into n cos nt minus gx into n equals to mu into 2a g square e raised minus gx into cos nt minus gx. So cos nt minus gx balances this. So likewise we can balance out a and e raised minus gx from both sides. So we'll get n equals to mu into 2g square. So from here I'll get my g as n divided by 2 mu under root. So this is the value of g, and I guess this is what we are supposed to show as value of g. So let's see it. Yeah, it is n divided by 2 mu. So let's move on to next question. So in the next question they have given us value of a u. Yeah, so they have given us u as x square tan inverse y by x minus y square tan inverse x by y. So if I take x square as common, so I will get tan inverse y by x minus y square by x square into tan inverse 1 by y by x. So you can observe that it is a homogeneous equation in y by x, in y and x, and it has degree 2 basically. So we'll be using Euler's theorem for this. So let us solve it. So by Euler's first theorem, we'll get x into del u by del x plus y into del u by del y equals to n into u, and our n is basically 2, so it will be 2 times of u. So if we take its derivative with respect to x, partial derivative with respect to x, so we'll get del u by del x plus x into del square u by del x square plus y into del square u by del x del y is equals to 2 into del u by del x. Likewise, if I take its partial derivative with respect to y, we'll get del x into del square u by del y del x plus del u by del y plus y into del square u by del y square is equals to 2 times del u by del y. Now if I just multiply this with 1 with x and 2 with y and then add, we'll get, so I'm doing is x into 1 plus y into 2. So let's see what we get. So it will be x into del u by del x plus x square into del square u by del x square plus xy into del square u by del x del y is equals to, plus this term, that is xy into del square u by del y del x plus y into del u by del y plus y square into del square u by del y square is equals to 2 times x into del u by del x plus 2 times y into del u by del y. So if we simplify it, so I am clubbing so I'll get, I can just simplify it, this term and this term I am taking it to the right hand side. So I'll get x square into del square u by del x square plus xy into del square u by del x del y plus xy into del square u by del y del x plus y square into del square u by del y square is equals to, will be left with del x into del u by del x plus y into del u by del y. This one balances, reduces this to x into del u by x, and this balance reduces it to y into del u by del y. So if you observe that our function u is basically a continuous function, So we can, and we know that for continuous functions, del square u by del x del y is same as del square u by del y del x. So we'll use this relation here. So we'll get x square into del square u by del x square. So it will be 2xy into del square u by del x del y plus y square into del square u by del y square is equals to x into del u by del x plus y into del u by del y. But using Euler's first theorem, we have calculated value of this term. So we find out it to be 2u. So from here I get x square into del square u by del x square plus 2xy into del square u by del x del y plus y square into del square u by del y square is equals to 2u. And that's what we are supposed to show in this question. So let's move on to next question. So the next question says that if fxy is a homogeneous function of degree n, it says that fx comma y is a homogeneous function of degree n, and it has continuous first and second order partial derivative. It further says that f has continuous first and second order partial derivatives, and then we are supposed to show these two things. So if you observe that these are basically Euler first and Euler second theorem. So the examiner is basically asking us the proof of Euler first theorem and Euler second theorem. So let's see. So let us assume that since it is given that f is a homogeneous function, so form of f I can reduce it to x raised n into f of v, where v I have assumed to be y by x. So let us assume this function as u. So my u of x comma y is basically x raised n into f of v, and where v is basically y by x. So if I take partial derivative of u with respect to x, I'll be getting n into x raised n minus 1 into fv plus x raised n into f dash v, that is y by x, and then partial derivative of v with respect to x. So this basically gives me n into x raised n minus 1 into fv plus x raised n into f dash v into minus y by x square basically. Likewise, if I find out values of del u by del y, then I'll be getting x raised n into f dash v into 1 by x. So this is basically equals to x raised n minus 1 into f dash v. So from here, if I solve it for u into del u by x into del u by del x plus y into del u by del y, so I will get n into x raised n fv plus x raised n into f dash v to minus y by x plus y into x raised n minus 1 into f dash v. So this is basically equals to n into x raised n fv plus x raised n into f dash v. It is x raised n minus 1 into minus y plus y into x raised n minus 1 into f dash v. So this one balances this. So from here we get x into del u by del x plus y into del u by del y is equals to n into x raised n into fv, that is basically my u function. So this proves the Euler's first theorem. So let's move on to prove Euler's second theorem. So in Euler's second theorem, we'll be using basically the Euler's first theorem. So let's name this as 1. So in the second part, we are supposed to prove Euler's second theorem, that is this. So for that, if I differentiate 1 with respect to x, so what I'll get is del u by del x plus x into del square u by del x square plus y into del square u by del y square is equals to n into del u by del x. It will be del x into del y because we are taking derivative with respect to x. Likewise, if I take derivative of differentiate 2 with respect to y, so I'll be getting del u by del y plus y into del square u by del y square plus x into del square u by del y del x equals to n into del u by del y. So let's name these equation as 2 and 3. And if you observe that in the question, it is given that the homogeneous function has continuous first and second order partial derivatives. So using that, we can say that del square u by del x del y is same as del square u by del y del x. Now if I multiply 2 with x and add it with the 3 multiplied by y, so y I'll get is x into del u by del x plus x square into del square u by del x square plus xy into del square u by del x del y is equals to n into x del u by del x. We're supposed to add, so we'll get plus y into del u by del y plus y square into del square u by del y square plus xy into, using this it will be same as del square u by del x del y, and this thing will be basically equals to n x into del u by del x plus y into del u by del y. So this basically gives me, I can write it as x square into del square u by del x square plus 2xy into del square u by del x del y plus y square into del square u by del y square plus x into del u by del x plus y into del u by del y is equals to n times x into del u by del x plus y into del u by del y. So from here what I'll get is x square into del square u by del x square plus 2xy del square u by del x del y plus y square into del square u by del y square is equals to n minus 1 into x into del u by del x plus y into del u by del y. But using Euler's first theorem, this thing is equals to nu. So we basically get n minus 1 into nu, and this proves our Euler's second theorem. So this proves our Euler's second theorem. So let's move on to next question. So in next question, we are supposed to show this. This is basically application of Euler's first theorem. So from here, I'll get my sin u as x cube plus y cube divided by under root x plus under root y, and I can write it as x raised 3 minus 1 by 2 into 1 plus y by x cube divided by 1 plus under root y by x. So this is x raised 5 by 2 into 1 plus y by x cube divided by 1 plus under root y by x. So you can observe that this is basically, sin u is basically a homogeneous function with degree 5 by 2. So let us assume that z is equals to sin u and degree is equals to 5 by 2. So if we use Euler's first theorem, then by that we'll get x into del z by del x plus y into del z by del y is equals to n into z. So from here we'll get x into del z by del x will be basically cos u into del u by del x plus cos u into del u by del y is equals to 5 by 2 into sin u plus y into del u by del y is equals to 5 by 2 tan u. So this is what we are supposed to prove. So let's move on to next question. I guess this is the last question there, and yeah, on this topic this is the last question. So that completes all the question of partial derivatives. So in the next video we'll see maybe limit continuity and differentiability of multivariable functions. So thank you for watching the video.